So this question says that we have a wheel that starts from rest and has an angular acceleration of 4 radians per second. When it's made 10 revolutions, its angular velocity is what? Okay, so what do I have? I have a wheel that starts with omega naught equaling 0. It starts from rest. We want to know what its final omega is at the end. We know that it's gone through a total of 10 revolutions. Well, I don't like revolutions. I know that one revolution is 2 pi radians. So 2 pi times 10 is going to be the number of radians that it goes through. So this is 20 pi radians. And we know that it has an alpha of 4 radians per second squared. All right, so what do we want to do? Well, we know that it goes through 10 revolutions. I'm going to start and say that I want to figure out, I know both of my equations have time in them, but time's not given to me, only the distance that it goes through. So I'm going to actually go through and write down omega final is equal to omega initial plus alpha t. I really want omega final, right? That's the value I'm looking for. Omega initial is equal to 0. So if I get omega final, it's because I have alpha times t. All right, so what is t? We don't know what t is. It would be nice if we had it. So if we can get this value for t, we're done with the problem. I'm going to need to use my other kinematic equation. Theta final is equal to theta naught plus omega naught t plus 1/2 alpha t squared. My theta naught, I have a change of theta, which is theta final minus theta initial. I'm going to say that my theta naught is equal to 0, so that means my theta final is equal to my change of the angle. So I get theta final is equal to 0 plus my omega naught is 0 is equal to 1/2 alpha t squared. Or theta final times 2 over alpha square rooted is equal to t. Just rearrange this equation. The 2 comes over the other side. I divide by the alpha, and I'm going to have to take a square root at the very end. So I come up with everything, and I will try to combine these 2 equations together. This equation and that equation together are going to combine it. So omega final is equal to alpha times the square root of 2 theta final over alpha. Or this is equal to 2 theta final alpha all square rooted. That's alpha square root squared. That's alpha square rooted. So I get an alpha square rooted on top. And I solve this equation by plugging in my values. I get 2. I go through 20 pi radians, and I go through an alpha of 4 radians per second. Gives me radians per 4 radians per second squared. So my final angular velocity is going to be, I have a factor of 4, so I get a factor of 4 out. I get square root of 10 pi. Square root of 10 pi is approximately equal to 4 times, that's 31. So this is 4 times a little bit less than 6, 5.8, 5.9. So 6, so I'm going 24. 4 times 6 is 24, a little bit less than that. I'm saying 22 radians per second is my right answer. So again, I'm doing these without a calculator to show that it is possible to do these and approximate, but the problem wasn't that hard. Solved one of our kinematic equations, came up with that dreaded time issue again, solved the other equation, substituted time in and eliminated it, solved the algebra, plugged in the numbers, and came up with our final answer of 22 radians per second.